Alright guys, welcome to office hours tonight. I am going to be going over some mostly review problems from problem sets 9 and 10. I'm going to start with problem set 10 because that's where I had a few more requests, and then I'll go, we can do some problem set 9 together too. I prepped for the stuff that was requested from problem set 10. So we'll see how far we get in that, and then after that I'll just be figuring out problem set 9 with you guys. So it's just me in here right now. I don't have any students in here to like field any questions, so if you have them, I would suggest emailing me, and then I'll stop at if I hear your email go off on my phone, which it usually goes off, I'll stop and look at it, and if the email at the end of a question, that'll be good too. So yeah, I guess I'm just gonna get started then. We open up problem set 10 with you guys. I had a question about numbers 3 and number 4, and then I'll move on to the review. Okay, so number 3, grading the TLE. So Professor Turley has to grade TLEs, which will take him 5 hours. The benefit of grading them is that the students get great feedback worth 125 units to Turley in the future. So note those utils are what occur for Professor Turley in the future. The cost is 5 hours of Turley's time worth 100 utils to Turley right now. So evaluate the net present value, benefit minus cost, of grading the TLEs under these scenarios below, and say if Turley will grade it today, intend to grade it tomorrow, or both. Okay, so scenario, let me just write that here real quick. So we have value of grading. So the value of grading is 125 utils tomorrow. Cost of grading is 100 utils today. And so Professor Turley in this problem has chosen these values. He says it. He just says that for him it's worth 125 utils tomorrow. For whatever reason, that's just what that's just when he receives the benefit for it based on what the problem tells us. And the cost is what he incurs today, which is the cost of grading. So I would assume that that's because he has to grade the papers today, and then whatever day he grades them, the next day he would be able to return them and feel the benefit of having graded them. So maybe that's why the utils of grading them don't happen until tomorrow. I'm not really sure, just kind of thinking about it. So scenario 1, in scenario 1, Dr. Turley values any cost or benefit in the future the same as present costs and benefits. So when we are looking at the value of grading today, it's going to be 125 utils of benefit that he receives tomorrow. So this is like benefit also. So it's going to be 125 utils minus the benefit minus the cost. So 125 minus 100 for total utils of 25. If he's indifferent between today and tomorrow for his preferences. If he grades tomorrow, he's still going to get 125 utils tomorrow because he values his time today and tomorrow the same. And any benefits he receives therein. And so he's still going to get 125 minus the cost, so it'll still be 25. So if he can anticipate these feelings, then he's going to be indifferent between grading them today and tomorrow. Okay, let me find this in the slide. Okay. I don't know where it is in the slides. Okay, so the okay. So this is greater than doing nothing, I guess. I'm not really sure why he has it set up as greater than 0. I'm sure he told you guys in class, but yeah, so if he does nothing today, then he gets 0 utility because he doesn't get this equation of, so I think I figured it out. So he doesn't get this equation of utility because he hasn't done either of these things. And so he would end up with 0 utility for the day. So this is if he doesn't act. But if he does act, he gets 25 utils. And so that would result in a decision for him to want to grade the TLEs today. The same is true of down here. The benefit of acting is right here, and the cost of not, and the benefit of not acting is right here, the net benefit. And so he's going to choose to act. So he's going to plan to grade TLEs tomorrow as well. Okay, so this is scenario A. I'm going to do scenario B. Okay, so scenario B says that Dr. Turley values any cost or benefit in the future at 80% of its present value. So we're looking at things that are happening in the future. So let's do this first equation again first, what he's going to look at, how he's going to look at these costs and benefits for today, and then we'll look at it for tomorrow. Okay, so today, he's going to be grading 100, so if Dr. Turley values his time today more than he values it in the future, basically saying that there's an inclination for us to want to be like immediate gratification in our actions. So we're more likely to watch an episode of Netflix than we are to do our homework, and we just think, I'll do the homework tomorrow, because something that sounds less savory we want to save for later, and something that sounds like more fun we want to do it right now because we seem to value our time right now more than we value the benefit that we'll receive in the future for doing something else. So that's what this is saying. So if he values any benefit that he's going to receive tomorrow at 80%, then we're going to multiply that percentage times whatever values he's going to receive tomorrow. So remember, back up here, he receives 125 utils tomorrow when he decides to grade today. So anytime he decides to grade today, his benefit is going to be backed up by 1 day. So he would get 125 utils of benefit, but not until tomorrow. So that's why we multiply it by this 80% number that he gave us, okay? And then we're also still going to subtract the cost that we're going to incur, and that cost is incurred immediately. So there's no discount on it. There's no 80% discount or 20% discount on it. So we just subtract the full 100, and 80% times 125 is 100. So 100 minus 100 is 0. And so this is, and that time, and this time it's going to be equal to what happens if he doesn't act at all. So this is going to be like the no, does nothing. In this little column here. Okay, so if he does nothing, he gets 0. So he's going to be indifferent about grading today. If he doesn't act, he doesn't get any utility or any benefit. But if he does act, he also doesn't get any utility or benefit because he values his time more right now than he does later. So he'll be indifferent here about grading today. So indifferent today. When he looks at tomorrow, he thinks, okay, so I'm still only going to get 80% of whatever benefit or cost that I seem to be incurring in the future. So we're going to do 80% times the 125, which would have already been happening in the future, no matter when he's looking at it, because he's always looking at it as I have to put the time in today to get the benefit tomorrow. So here, this is a future, something that happens in the future. He receives this benefit tomorrow. So rather than doing his grading today, he's looking forward and saying, okay, I'm supposed to get 125 utils out of this, but I only really feel like in the present, it only really feels like I care about, it feels like I care about those a little bit less. So we're also going to multiply this 100 over here times that 80%. Because if Dr. Turley's living in this world where this is today and this is tomorrow, then everything happening down here, all the costs and benefits, so here are the benefits and here are the costs, are going to be looked at differently. Discounting all those things at 80 by 20%. So in this case, we're going to have 100, which is 80% of 125 minus 80. So it's going to equal 20 over here. And 20 is greater than 0. So he's going to plan on grading tomorrow. Okay, now let's do part C, which I think is just a 50% discount on the present value. Okay, so part C, here's today. Dr. Turley's sitting down, he's trying to do his economic calculations about whether or not he wants to do grading. And he thinks to himself, hey, I'm going to get 125 utils out of this, but it's not going to be until tomorrow. And so I don't really value tomorrow as much as I value today. In fact, I only value it half as much. So I'm going to multiply that benefit times 0.5. And if I grade today, I have to pay 100 utils today because that's how much it's costing me. It's an inconvenience. I'd rather go exercise or whatever, go on a date or something. And so he's going to still subtract the full cost for him today because he values his time today 100%. And so he's going to get, what's 120? So 67.5 utils over here minus 100. So it's going to be 32.5, negative 32.5 utils over there if he decides to grade today. And if he doesn't decide to grade today, if he doesn't get this benefit and this cost, then nothing happens. He doesn't get any utility out of doing nothing. And so we compare this negative 32.5 utils to the 0 of doing nothing, and he would actually be worse off if he graded today because he values his time today more. And so it's not worth it for him to do the grading today. So he's going to plan to grade tomorrow. Or maybe he'll plan to grade tomorrow. We have to look. Not grade today, for sure. For sure he's not going to want to grade today. So let's check to see if he wants to grade tomorrow. So he's going to do 125. That's how much benefit he's going to get from grading. But he's going to discount that by 50% because it happens in the future. But he's also going to have to consider the cost. But the cost, if he's looking at whether or not he wants to do it, Dr. Turley's calculating on this day, on day 1, and he thinks, tomorrow what will I calculate? Like, what will I feel? Then he's going to say, then this cost is also going to be incurred tomorrow. He's looking forward to tomorrow. So in this case, we'd have 67.5 again. Is that right? Yeah. No, it's not right. I think it's 62.5. 62.5 minus 50. And so he's going to get 12.5 utils. Looking forward to it, he's going to think that he's going to get 12.5 utils tomorrow, which is obviously greater than doing nothing tomorrow. So he's like, yeah, I don't want to do it today, but tomorrow I'll probably feel like it. That's his calculation today. But part D asks another really important question. What is strange about this 50% discount preference? What's strange about it is that, so say we're looking at, I'm going to think of these as like day numbers rather than just saying today and tomorrow over and over again, because maybe there's some important, guys. So day 1, day 2, and day 3. So if Dr. Turley's thinking about this on day 1, then there's one present cost that he can see, and the benefit he'd receive is in the future, so that's why I discounted it. And when he looks forward to tomorrow, everything is in the future. But once he moves from day 1 to day 2, once it's actually day 2, he's not going to find that this is the calculation anymore, because he's going to do the same. He's still going to suddenly tomorrow will be today. This is kind of getting loopy. But once tomorrow becomes today, so once I decide not to do it, I go to bed, I wake up, and I think, okay, yesterday I decided I was going to do it today. I'm going to realize that I have the same problem. It's tomorrow when I think about it again. I'm going to be stuck back in this world where it's going to be, I'm looking at my costs and I don't get all the costs, I don't get all the benefits right away, but I get all the costs right away, and I value them at the full capacity, at the full cost, and it's going to be a negative. I will still decide not to grade today. So, this is going to happen to me every single day until some of these utilities change, or until I quit discounting the future at 50%, or until Dr. Turley gets fired for not grading the TLEs. So it's really good that he doesn't actually live in this world, or it's good that he hires TAs to do it. So, yeah. So if that makes sense, every time we think to ourselves, I don't want to do it today, I'll plan to do it tomorrow. I mean, I'm sure we've all experienced this. Tomorrow comes and we think again, well, now I don't want to do it because I could do something fun right now, and I value fun in the present more than I value benefits in the future and doing the responsible thing. This is something we all struggle with, right? Is thinking, yeah, it sounds like it's an attractive idea for me to plan to do it tomorrow until tomorrow comes. and then suddenly it feels like today again, and we value our present time more. So that's number 3 from problem set 10. Okay, so number 4, I'm going to move on to number 4 in problem set 10. Okay, so number 4 said, what's the expected value of a dice roll? Let me look up the definition of expected value really quick so we can draw on it. Okay, so the definition, as we have it on the slides, is for an event that involves risk or chance, it's the expected value is the calculation based on the probability of different outcomes of the value of the event in expectation before the outcome is certain. So it's almost like if I drew an infinite number of times, or for number 4, I should think about it like this. If I rolled a dice an infinite number of times and took the average of the infinite number of rolls, I would get the expected value. But we can also do that by just multiplying by the exact probability of each value that we end up on. So there's a dice has 6 sides. So anytime you roll it, there's going to be a 1/6 chance that you get any certain side. And dice are also, every side has a different number on it. All, numbers 1 through 6 occur one time for each on every dice. So we have the probability and the values. And so to get the expected value, we're going to multiply. We just think about it. Okay, what's the probability of rolling a 1? The probability is 1/6, right? It's going to be that way for everything. And then what's the value of rolling a 2? 1/6. And what's the value of rolling a 3? 1/6. And so on. Okay. So anytime I roll a dice, this is basically the full gamut of what can happen and the probability of each option. So anytime I roll a dice, there's a 1/6 chance it hits a 1. There's a 1/6 chance it hits a 2. There's a 1/6 chance it hits a 3. 1/6 chance it hits a 4. 1/6 chance it lands on a 5. And 1/6 chance it lands on a 6. And that represents all the possible situations with their respective probabilities for any certain dice roll. So when we go ahead and do this math, it's going to be 1/6 plus 2/6 plus 3/6, so plus 4/6 plus 5/6 plus 6/6, and that is going to end up equaling. So this is 6/6. This is 6/6, and this is, so that's 2, and then this is 9. So 3.5. Just when you do the addition, you end up getting 3.5 for the expected value of a dice roll. My theme. If you don't think about it, if you don't think about the way that the dice is set up or the die is set up, this might seem like a weird number. It might seem like, well, if it's up to 6 and there's an equal chance of any of the options, then it seems like the probability, the expected value would have been 3. But that's not true because there was no 0. There was never a 0 times 1/6. or I guess it would have been, if there would have been a 0 on the dice, then all these things would have been times 1/7, and then you would have gotten that different answer. But you only go from 1 to 6, so it's almost like, yeah. Anyways, that's how you do expected value. If there could possibly be a situation where there's a different probability for each option. I've seen dice before where there are maybe a couple sides that have 1s, a couple sides that have 2s, and a couple sides that have nothing. And so in that case, you'd have 1. So there'd be a equal chance of getting. So there'd still be 6 sides of the dice. So you still have a. Okay, so let's say there's on 6 sides of a dice, there are 3 1s and 2 2s and 1 0. Then we would have there would be a 3/6 chance because there are 3 sides that have 1s on it. So there would be a 3/6 chance of hitting a 1. There would be a 2 sides have 2s on them, so there would be a 2/6 chance of landing on a 2. And there would be a 1/6 chance of landing on a 0. And so that's how you do it if there are different probabilities for each one. But this is the problem from problem 4 right here. Okay, now we're going to move on to number 7, which is loads of fun. It's a review question on game theory. So, yeah, let me pull it up real quick. Let me check my email because I don't see any viewers right now, guys. Ah, I forgot to send the actual link. That's what's the problem. Sorry. I'm sorry, guys. I totally forgot to actually send the link. So, for those of you who end up getting on now that I've actually sent the link, I have gone over problem set 10, numbers 3 and 4. So if you have questions on those, you can go back and watch the first half hour of the session later on if you'd like. So I'm now going to get started on problem set 10, number 7. And we have a centipede game. So I'm going to draw that up on the board first. Okay, so I'm just going to draw it exactly as it is in there in the problem set. So Amy and Betty are playing a game. Amy gets to go first. All of these arrows down here represent the decision to keep. So this is if Amy decides to just keep the prize and not play the game anymore, and Betty can make the decision to do so if the turn gets to her as well each time. So all of these represent the decision to pass, to let the next person decide whether or not to pass or keep. So this is a pass, pass, pass. Okay, so the payoffs are represented by these numbers in parentheses. So for example, if Amy just chose to end the game as soon as it started, she gets move 1. This is going to be Amy here is move 1, Betty here is move 2, Amy is move 3, Betty is move 4. So if Amy in her first move decides to keep the prize, we'll just call it a prize in each of these cases, then the game ends, and Amy gets 2, and Betty gets nothing. Betty gets 0. If Amy decides to pass, then Betty suddenly gets to decide whether or not she wants to keep or to pass. And so if she would keep, she would get 1, Amy would get 1, and Betty would get 3, but the game would end there. So the game ends, and the prize is decided as soon as someone decides to keep. And if no one decides to keep ever, if Amy passes it, and then Betty passes it, and then Amy passes it, and then Betty passes it, then they get to this end over here. So that's the only way that the game will. If they get all the way over here, the game ends. Or if anyone picks keep in any of their turns, the game also ends. And so we are tasked with converting this extensive form game into a normal form game. There's not a key on this or anything, so I just thought about it and tried to figure it out. And so I'm just going to show you guys what I came up with. So in any normal form game, we're going to have the two. This is similar to the question that we had before, where person A got to decide whether or not to let person B choose between. Person A got to decide whether or not to offer person B $1 or $5 of a $10 pot, and person B got to decide whether or not to keep it or to reject it, and no one got anything. So in that game, we had a column that was one was $9 and one was $1, because those are the two decisions, or one was $1 and one was $5, and those are the two decisions that person A was able to make. And then person B was able to decide whether or not they're the type of person who would reject and then or accept each of those deals. So I'm going to put my normal form game with Amy on one side and Betty on the other, and then I'm just going to write down the possible options that they could choose in this game. Okay, so Amy can decide, she might be the type of person who would keep it immediately. It would just take this action right here and end it right away. She might be a person, so that's if move 1 is a keep. So I'm just gonna let these little numbers next to the letter or the decision indicate which turn the decision was made in. So like this 1 corresponds with Amy's first move. So this is move 1. And Betty gets to make move 2, and Amy makes move 3, and Betty makes move 4. Okay, so Amy could be the type of person, though, where she would pass on move 1, but keep on move when she gets her move again, which is not going to be until move 3. Or she might be the type of person who would pass on move 1 and pass on move 3. But you see that Amy only gets to make 2 decisions here, right? She gets to make decision 1 and decision 3, and Betty gets to make decision 2 and decision 4. Okay? Betty, on the other hand, so this represents all the decisions that could be made. So she could either keep and then the game ends, which is why there's no keep option, because and there's also no keep pass option, because once the keep is decided, none of those ever exist anymore. I mean, we can draw them up there if we'd like to anyways, but those situations would never, the second move here would never actually happen, because by the time, as soon as she makes this decision, the game ends, right? As soon as the keep is the first one, there is no more second, there is no more turn for Betty or for anyone. Okay, Betty, on the other hand, can make all these different moves as well. She could be the type of person who's planning on keeping it as soon as she gets it, and she's going to get it in move 2. Or she could get it and keep it in move 4. She might be the type of person who would keep it in move 2, do nothing in move 4. But again, the game actually would, if Betty actually had the opportunity to keep, the game would end right after she kept it, because this would be to say that she, Amy passed, and then it got to her and she kept. So there is no more Betty over here choosing to pass and keep, which is what's happening right here in this second letter. She can also decide to pass, keep, or to pass, pass. Okay, so now I'm going to draw this extends this game here. Okay, so here we are. If you notice, this Amy side has only decisions that Amy makes. She only makes decisions on turns 1 and 3. And Betty's side only makes, she only makes decisions on 2 and 4. And this KK indicates that, or this PP indicates that Amy is the type of Amy that would choose to pass on both of her turns. Okay, so now we're going to fill this in. If Amy goes first, or Amy does always go first, and if she's the type of person that's going to keep, then the game is immediately going to end and the payoff will be 2-0. And it doesn't matter what type of Betty we're dealing with, because Betty never even gets to move. She doesn't even get to, really play the game, because Amy already ended it. So no matter what type of person she is, Amy ended the game already by keeping. The same is true in this situation, because it's once again Amy's keeping in her first move, which is this first letter K here. And so there's nothing Betty can really do. If that's the type of game that Amy wants to play, then Betty doesn't get any option. It's just all the same. She only is going to ever get 2-0. If Amy is the type of Amy that would pass, and if Betty is the type of, so that's what happens in move 1. Amy passes, the P1, and then we look at move 2, and it looks like Betty says that she's the type of Betty that would keep. So if Amy passes and Betty keeps, which is what happens here, move 1, move 2, then we go pass, Amy passes, Betty keeps, and we have a payout of 1-3. If we're dealing with the type of Betty that is also, so sorry. Okay, so for the next one, Amy is going to go first. She's going to pass. We're just looking at all of this one right here. Amy passes, and now we're going to look here. What does Betty do on move 2? She keeps. And what happens? Amy passes, Betty keeps. So it's going to be another place where this is where the game ends. If we're in the world where Amy first passes, and then the second move is that Betty also passes, then Amy gets to make another move. She gets to her third move, or the third move. And she's going to decide to keep right there, based on this version of her. So that's when the game would end at 4-2. If Amy passes, and then second move here, Betty passes, and then it comes back to Amy, and she keeps, another place where it's going to be 4-2, right? Okay, now we're going to deal with a different Amy. We're going to deal with the Amy that passes every time. So she passes in move 1, and in move 2, Betty keeps. So Amy passes, Betty keeps. We get another situation where 1-3 is going to be what happens. Same here, because Amy's going to pass and Betty's going to keep again. Here we get an interesting thing. Amy's going to, in this situation right here, Amy is passing for her first move, and then Betty is passing for her second move. So we have a pass and then a pass, and then Amy is passing for her third move as well, right here. So we get another pass to Betty, and then Betty's last move is to keep. Boom. She goes down right here and she says, so Amy passed, Betty then passed, Amy passed again, and then Betty decided not to pass again. She decided to keep. So the game would end with this outcome, those payoffs. And if we get a situation where Amy always is passing, and so is Betty, we get Amy first passes, then Betty passes, then Amy passes, and then Betty passes. So we get pass, 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 and then everyone ends on 4-4. So that is the normal form of this extensive form game over here. I'm really sorry, it's really ugly. Got a small whiteboard. Yeah, so just once again, guys, these little subscripts here indicate which move it is. And so we see over here that since these are happening sequentially, Amy gets the first move, and then if she decides to let the game go on, Betty gets the second move, and then if the game goes on, Amy gets the third move, Betty gets the fourth, and then the game is going to end somehow. So these little sub things indicate which move we're talking about. So Amy's first move or Amy's second move, which turns out to be the third turn. And I just did that so I could keep track of which one of these letters I should look at. I'm going to look at the first letter first, and then I look at this letter, and then I look at this letter, and then to know how the game is going. Okay? I'm just checking to see if you guys have emailed me with any questions. Okay. So now we're going to B. Okay, so Nash equilibrium again, guys, is when we consider what the other players are doing, Each player should be maximizing his or her own payoff. So we're going to be looking at Amy's decision and decide, given if we knew what kind of person B was, would Amy have any incentive to move to a different place, to make a different decision and be a different type of Amy? Okay, so that's what we're going to do first. And I'm going to do this by circling a number when I decide that it is a desirable number for one person, okay? So let's say, right now we're going to look at what where Amy wants to be. And we're going to do that by looking at each of these types of Betty that we could be dealing with and figuring out the Nash equilibrium. Okay, so given that, so if this is the type of Betty that we're dealing with a keep Betty. She wants to just end the game as soon as she gets the chance, pretty much. Then which of these payoffs, because A's payoff comes first, which of these payoffs would Amy prefer? Well, she would prefer a payoff of 2 over these payoffs of 1, right? Let's say we're dealing with this type of Betty. Once again, Betty is the type of Betty that's going to end the game as soon as she gets the chance. And if Amy were able to know that, she would prefer getting the payoffs, either of these payoffs of 2 over a payoff of 1, right? Okay. Let's say we're dealing with this type of Betty, where she's planning on passing the first time, and if she gets it the second time, she's planning on keeping it. So let's look at all the payoffs for Amy and see which of these she would prefer if she knew that Betty was going to play that way. Well, player A's payoff is maximized right here. 4 is greater than 3 and it's greater than 2. And then over here, if Betty is the type of girl who's planning on passing no matter what happens, then player A is going to want to be in either of these places where she gets a payoff of 4 rather than a payoff of 2. So these are the places from which if Amy was in either of these orange places, she wouldn't benefit by moving to any other decision. Okay? If Amy were playing this kind of Betty, and she could somehow know that, then she would know that there's no benefit for her of playing where she doesn't keep it first. If she passes first, she gets a payoff of 1. And if she keeps it first, she's going to get a payoff of 2. So that's how we did that. Now let's look at it for Betty. Given that let's pretend that Betty knows what kind of Amy that she's dealing with. So we're going to decide which decision Betty should make based on any certain Amy. So if Betty is dealing with this type of Amy, if Betty is dealing with an Amy that's going to keep it in her first move, what decision would Betty want to make? Okay, so we're going to look at all of these. This is a decision where Amy keeps, and these are the possible payoffs that Betty can choose between. Well, they're all 0, right? Any payoff that Betty can get in this case is going to be 0. There's nothing she can do because if Amy keeps it, the game ends. The same thing is true in this situation because Amy kept it in the first place again. So if Amy chooses to keep, there's nothing Betty can do. All of those she wouldn't stand to benefit by being any certain type of Betty, making any certain type of decisions and any moves, because no matter what, she just gets a payout of 0. It doesn't matter which decision she makes. If Betty is dealing with the type of Amy, though, that is going to pass this first time, then where does Betty want to be? Well, Betty wants to be in a place where we're looking at all these different outcomes for Betty, and she would prefer either of these two payouts of 3 over those payouts of 2. So if she knew that she was dealing with the type of Amy that's going to pass the first time, she's going to want to keep it. And then finally, in this last situation, if she knows that she is dealing with the type of Amy who's going to pass every time, which of these outcomes would Betty most want? Well, she's going to prefer this outcome of 5 the most, right? So if Amy passes it twice, Betty's going to keep it the second time it gets to her. And she's going to get a payout of 5. So anywhere where we've circled 2, any of the places where we've circled 2 of their numbers in orange is a place where there's a Nash equilibrium, where neither player would stand to benefit, given these facts about how they're playing, to move to a different decision. So if Amy keeps and Betty decided that, she was this kind of Betty, it doesn't benefit her any to try and be a different kind of Betty. But if Amy were to decide to pass the first time, right here, it benefits Betty to be one of these 2 types of Betty, where she gets a payout of 3, instead of one of these 2 types of Betty, where she gets a payout of only 2. Okay, so these are the places where there's no incentive for anyone to move. Okay, I think the next part of the question is, let's see here. Identify the sub-game perfect Nash equilibrium. And I actually had to look this up online because it wasn't in the slides. And I don't have it anymore, so I need to look it up again. But it's when you find a Nash equilibrium that is this is what Google says. The subgame perfect Nash equilibrium is a Nash equilibrium basically that is the best option in every single subgame of the original game. So a subgame is any one of these different moves is a subgame. So this is the entire game, and there are lots of different there might be lots of different Nash equilibrium within this entire game. But when we look at each one of these subgames, we want to pick the Nash equilibrium that would be best. And that is a subgame perfect equilibrium. So the subgame perfect equilibrium for this first move. Okay, so we want to start working backwards, I think, as our Dr. Shirley taught you. So when we look at, we're working backwards, and we start with move 4. What is Betty going to want to do? Between this and this, she would choose to keep, right? And Amy, seeing that, would want to choose, she would choose between this and this. And she would rather have 4 than knowing that Betty's only going to give her 3. So she would choose to keep there. But knowing that, Betty wouldn't have passed it to her in the first place, because she would have been choosing between 1 and 2, between 3 and 2, and she would have rather had this 3. So we never even would have gotten that far. And Amy wouldn't have passed it to Betty there, because she wouldn't have wanted to get because Amy would prefer to have kept it herself and gotten this too, rather than passing it to Betty and knowing that Betty would just get that Amy would just get one there when Betty ended up keeping it inevitably. And so we get back to this. We get back to this first move, this sub game. I'm going to erase all of this, guys, now, and then just show you the first sub game that we worked back to, because that's the only place where Nash equilibrium occurs, is in the first game. Okay, so in the first game, Amy decides either to keep or to pass. If she keeps, she gets 2-0, and if she passes, Betty makes the decision to either keep and end the game at 1-3 or move on and so forth, right? But all of these Nash equilibrium that we found were actually in the first move of the game. Because if Amy decides to keep in her first move, which is happening in both of these situations, then when Amy keeps, the game ends. You see here, if you can have more than one sub-game perfect Nash equilibrium. So I'm not sure if you can have more than one sub-game equilibrium or sub-game perfect equilibrium. So this is the normal mode. That's how you would come up with it. And I would maybe just ask Dr. Turley about the sub-game perfect equilibrium. I don't remember exactly how, all the rules about those. So I'd ask him. Okay, now I'm going to move on to problem set 10, review questions, because that was the next thing that was requested. Okay, so let me open up problem set. Oh wait, sorry, I was already on problem set 10. I'm going to move to problem set 9 and work on the reviews because those were the most requested. So George operates Mountain West Burrito on the south side of BYU. We're supposed to assume that it's the only place anyone can get a burrito in Provo, aka the Monopoly. And we have a table below that tells us everyone's willingness to pay. And we also know it costs $4 to make a burrito. So use the total revenue and marginal revenue for So use the chart to calculate total revenue and marginal revenue for Mountain West Burrito. Okay, so I'll draw this up here. Okay, so A is willing to pay $21 for a burrito. B is willing to pay 18, 15, 12, 9, 6, 3, and 1. So these are the amounts that everyone's willing to pay for a burrito, and the only place they can get a burrito is Mountain West. So if Mountain West were to sell this burrito to person A, they'd sell it for $21, and their total revenue would be $21 because they only sell one burrito, because no one else would be willing to pay the $21 for a burrito, except for this crazy guy. Okay, if they are going to sell two burritos, or if they want to sell to these two people, then they're going to have to lower the price to $18, and then they'll sell a burrito to anyone who values a burrito at least $18. So this person values it at $18, and this person values it at over $18. So they'd sell two burritos. So 2 times 18 would be $36 that they would get in total revenue from those two customers. Here they would sell 3 burritos because they'd sell to this person. So if they wanted to sell 3 burritos, they'd have to drop their price down to $15. And then they would have this person, and this person who were willing to pay $15, and they would make a total revenue of $45. Here they would sell 4 burritos, so they get $48. Here they'd sell 5 burritos, and they get $45 for total revenue. So now we see their total revenue is going down. Here they would sell 6 burritos and get $36. Here they'd sell 7 burritos, get $21, and here they'd sell 8 burritos and get $8. So the marginal revenue for the first burrito, the marginal revenue is $21. Just for moving from making 0 burritos to that first burrito, they would make $21 whopping in marginal revenue. If they decide they want to sell 2 burritos, and try and get this guy too, then their total revenue goes up by from 21 to 36, which is 15. Here their total revenue goes up by 9, I think. Yeah. Here their total revenue goes up by 3. So that's their marginal revenue, is how much their total revenue increases by. Here their marginal revenue goes down by 3, goes down by 9, goes down by 15, and then goes down by 13. So that's for A. We calculated the total revenue and the marginal revenue for Mountain West Burrito and for each of these numbers of customers and their willingness to pay. So now for part B, it says, suppose it costs $4 to make a burrito. What is a socially efficient number of burritos to sell? If it costs $4 to make a burrito, it would be socially efficient for Mountain West Burrito to produce a burrito for everyone that values it at least $4. So if we look at the willingness to pay, everyone up until person F, who values it at $6, values it more than the cost to produce. And so that would be the socially efficient number of burritos. So the number, that would be 1, 2, 3, 4, 5, 6 burritos. Because if the marginal cost is $4, okay, everyone values it at more than what the marginal cost is. Okay, part C says that if George decides to sell the burritos for $6, so let's say he does decide to do the socially optimal thing and sell them for $6, what is the surplus for Mountain West Burrito, and what is the surplus for customers? The surplus for Mountain West Burrito is going to be their revenue minus their costs, right? And so they're going to get $6 per burrito. So they're going to get $6 per burrito, and they're going to sell 6 burritos. So the revenue is going to be $36, and their costs are going to be $4, because that's how much each burrito costs to make, times the 6 burritos, for a total cost of $24. And so the surplus that Mountain West Burrito will receive, or George will receive, is all the revenue that he received minus the cost it took to produce it. So his surplus is going to be 12. The surplus for the customers is going to be the difference between the price that they paid and the price they were willing to pay. So for this guy, he was charged $6, and that was all he was willing to pay, so he doesn't get any surplus. This guy was willing to pay $9, so he gets $3 in surplus. This person was willing to pay $12. Again, they only paid $6, so they got 6 in surplus. And then that's how you're going to figure out everyone's surplus, is by subtracting that cost that they paid. And then the total consumer surplus will be all of these numbers added up. So we get 3 plus 6, 9 plus 9 is 18, plus 12 is 30, plus 15 is 45. So consumer surplus is all those numbers added up for 45. If George decides to profit maximize and he can only sell at one price, what price will he set? So we remember, guys, that he's only going to sell until marginal cost equals marginal revenue. And once his marginal costs are greater than marginal revenue, he's not going to sell any more. He's not going to sell that burrito. He only wants to sell it if he makes more on it than he does than it costed him to produce it. Okay. I'm going to erase all this. Okay, so the marginal cost is always going to be $4 for him to produce a burrito. And we want to look at where this $4, wherever the marginal revenue is above that $4, they'll keep selling, right? 21 is above 4, 15, 9, 3. So here's where his marginal revenue is less than his marginal cost. So he doesn't want to sell to that person because it cost him $4 to make the burrito, and he's only making an additional $3 on that burrito, on that one additional burrito. So it's not, if that wouldn't be a profit maximizing decision to keep selling after this person here. So, but on this person, he made a marginal revenue of 9, and he only cost 4, so that was still a profit of 5 for him. So he's going to choose to sell at this point here, which corresponds to this point over here. So he'll sell his burritos for $15, and he'll only sell 3 burritos, but he will maximize his profit that way. His profit's going to be his marginal revenue. Oh, sorry. Yeah, his profit's going to be his marginal revenue minus his marginal cost each time for each of those burritos. So it'll be 5, 11, 17. And if we add all those numbers up, we'll get his total profit. Oh, I'm sorry, guys. That was wrong. I'm sorry. That was wrong. Total profit is the $15 that he's going to make on everybody minus, so he's going to make $15 times 3, and it's going to cost him $4 times 3. That's the way to do it. We'll get 45 minus 12 for 33 in profit. And he's the one, so he'll get this much in consumer surplus. That's his consumer surplus, is his profit right there. And then the consumer, so this is producer surplus, and consumer surplus is going to be 21 minus the 15 it costs them to buy it, 18 minus the 15 it costs them to buy it, 15 minus the 15 it costs them to buy it. So we're going to add up 3 and 6, and we'll get the consumer surplus is 9. So added up together, this total surplus is 42. And I can't remember what I wrote down over there before when I showed you guys what the surplus was before, but you guys should have probably written down what we came up with for the surplus when in the socially optimal place where he sold at $6. It would have been so before, I just recalculated it real quick. Before, when they were selling at the socially optimal place, they were selling at $6 a piece, and the total surplus for customers was 45, which was these numbers added up. We'd have 9 plus 9, which is 18 plus 30, 45. So this was consumer surplus before, and this was producer surplus before. And so before, when they were selling at socially optimal point, it was 57 in total surplus. And now they're only getting 42 in total surplus with a monopoly, which means they lost 15 in total in surplus, right? Because 57 is 15 more than 42. Okay, so now we have number 2, which is building on number 1 in the review. So using the information, we have to graph the demand curve, the marginal revenue curve, these prices, surplus, and deadweight loss. Okay, so I'm going to graph all those things on the other whiteboard. Price, quantity, price. Okay, so demand curve is going to be based on how many people are willing to buy at each of these price points, right? So we'll have a price point at 21. And then we've got 1, 2, 3, 4, 6, 7, 8. Okay, so when the cost is, if the cost were $21, how many people would actually demand a burrito at that cost? One person, right? Person A. If the price were 18, 2 people would want it. If the price were 15, all 3 of these people would want it. And so it just it's going to go down this like this. It's not perfect, but it's supposed to be like a straight line going down 1 each time until it gets here. Okay, so this is demand. The marginal revenue curve is going to be half of the demand curve. So we also have the numbers. So there's going to be one person. There's going to be the marginal revenue at this willingness to pay 20 for person A, quantity of one is 21. The marginal revenue for B, 15. The marginal revenue for C is 9. So this is like 1. These are like quantities 1, 2, 3, 4, 5, and so on. So when the quantity is going to be 3, marginal revenue is 9. we're going to end up with the marginal revenue curve something like this. Of course, I have all of the points that I would need to actually draw this out perfectly, but I'm not going to take the time to do that. Basically, this would be the quantity, and this would be the p-value over here on this y-axis. We've talked about a couple of different prices in this problem. We talked about a price point at $6. We talked about a price point at $15. Yeah, so those are a few price points we talked about. It says a graph price. I'm not really sure what you mean. We've got, oh, I need to graph supply. So marginal cost is 4, is right here. So we have, if this were the price point at $6, consumer surplus, the producer surplus would be everything underneath that $6, everything, the difference between the cost and that $6, until this quantity over here that he would sell. That's where the $4 hits the answer. But let's see here. If we're going to do the last price that we talked about, which is the profit maximizing price, we would have a consumer surplus. So let's see here. This is where our price point would be. The producer would get well, first of all, if you only sell this quantity, right? Which should actually line up with 3, not 4, just because of my drawing. So this is actually a quantity of 3. And so the producer would get all this red surplus, which would be the area underneath the price. And so anything above this marginal cost that he takes and the price that he would receive for that. And then finally, consumers would get the area under, they would get the, this is their surpluses, however much more they valued it than $15. So for this person, the $21, this length would be 6, because he's 20, the difference between 21 and 15 is 6. The person who valued it for $18 gets a surplus of 3, and the person who valued it at $15 doesn't get any surplus. The dead weight loss that results is these transactions that would be happening at the socially optimal point that didn't happen anymore. That's dead weight loss. So those are the 2 review questions from problem set 9. We did some problems from problem set 10. And that's all I've gotten from you guys for requests, so I'm going to stop here. I'm sorry I forgot to send out that YouTube link. I totally just forgot to paste it in the email, which was really airheaded of me to do. But again, you guys can watch the couple. If you missed anything because of that, I mean, you can go watch it on YouTube, so that's good. I'm sorry that you guys didn't get to ask questions, though. Yeah, let me see really quick what my schedule looks like for Saturday. I'll send you guys out an email and talk and let you know about Saturday, as it gets closer. And yeah, I'll see you guys later.